Time to do some homework. Use the distributive property to rewrite each expression. So I put these on there just to get your mind prepped for the next set of questions. 10 times 9 would be 90. And 10 times negative 2x is negative 20x. Done. Number 2, the thing about this one's different is we have a negative, that's complicated, and there's also an extra x in front. So careful here, that's negative 2x times a 1x, which would make negative 2x squared. Now I'm going to take negative 2x times a negative 6. Negative times negative is a plus, and then 2 times 6 is 12. And don't forget the extra x that goes with it. Number 3, distributing a negative 3 times 4, so that's negative 12x squared. Negative 3 times a negative 6 would make plus 18. Don't forget your x. And negative 3 times 1 would be negative 3 or minus 3. That's the end of that. So 4, 5, and 6 are going to be the reverse of that. Generally it's called greatest common factor or factoring with a GCF. So what I want to look at on number 4 is, what can I divide both of these numbers by? Well, since 2 goes into 6, and 2 also goes into 20, that's going to be their greatest common factor. There's no number bigger that divides evenly into both. So what I'm going to do is put that out in front of my parentheses. Remember, we're reversing the distributive property. 6 divided by 2 would be 3, and 20 divided by 2 would be 10. And I hope that you can see that if you were to go through and do the distributive property, 2 times 3 would be your 6, and 2 times 10 would be your 20. Notice that the numbers 3 and 10, they do not have a common factor to reduce that any farther, so we did the right thing. Looking at number 5, we have to figure out what number goes into 20 and 40. Well, 2 goes into both, but that's not the biggest number. 5 goes into both, but that's not biggest. 10 goes into both. The biggest number we can do is 20. So I'm going to divide both of these numbers by negative 20. I noticed that there is a negative in front, and that's what we want to bring out. If there's a negative in front, you definitely want to factor that out for some future things we're doing. Those negative 20 divided by negative 20 is 1, so I'm just going to put an x. And then 40 divided by negative 20 is negative 2. You can just sort of check back through your work. Negative 20 times 1 would be negative 20, and negative 20 times 2, negative 2 would be positive 40. So, and now number 6, actually easier than that. You can divide each of those by 5. That gives me 5 times 5 divided by 5 is 1x, and then 15 divided by 5 is 3. Just bring that minus sign down with it. You're done there. I wanted you to keep practicing your double distributions. So here goes 7, 8, and 9. X times x, x squared. X times negative 6 is negative 6x. 4 times 1x is a positive 4x. And 4 times negative 6 is negative 24. The middle two for me are like terms. They're going to combine to make a negative 2x. I'm just going to bring down the x squared in front and the minus 24, and we're done there. 3x times 1x is 3x squared. 3x times negative 8 is negative 24x. 5 times 1x is positive 5x. And finally, 5 times negative 8 is negative 40. The middle two combine again. Negative 24 plus 5 is negative 19. Bring down the minus 40, and we're done there. Number 9, something's interesting going to happen here. You notice that the numbers are the same, but this one's a plus and this one's a minus, so watch what happens when that happens. 2x times 2x is 4x squared. 2x times negative 6 is negative 12x. 6 times 2x is positive 12x. Should be noticing something there. And now 6 times negative 6 is negative 36. So what I've been hinting at is that those two middle numbers are opposites of each other because of the way the problem was created. And so they cancel themselves out, giving you basically 0x, so I'm not even going to write it. And we get, just bring down the minus 36, and I don't know why I wrote those so far apart. So final answer, 4x squared minus 36, and you're done. So if you watch out for that, you can actually speed yourself up and just skip the two middle parts and go 2 times 2 is 4, and 6 times negative 6 was negative 36. And then you would know that those middle two are always going to cancel out when the problems are sort of the same like that. Finally, number 10, just wanted you to practice using a table. I've just been noticing students that are forgetting how to fill in their tables or feeling uncomfortable about that. Remember that these X numbers are your input numbers. They're going to input into that X and that X. But do remember, especially since we're about to put a bunch of negatives into here, you really need to understand that there's parentheses around that if you're using a calculator. Because this right here means a number squared. So you have to go, what is negative 5 squared? Well, that would actually have to be positive 25. But if you ask a calculator to do it, it's not going to do that. It's going to do 5 squared is 25 and then throw a negative on it. It's just the way calculators work. So be careful there. If you do this correctly, like I said, you'd be typing in, negative 5 squared plus 4 times negative 5 plus 3. That's going to be, I want to say that's 8. Hope I'm right. I'll find out here in a second. I'm going to pause the video now and fill in the rest of the table. Okay, I finished filling in my table. Notice that this is a quadratic function, and if you do the right x values, you will often see an interesting pattern that repeats itself. So this one, it's 8, 3, 0, and then it gets to what is basically the lowest point of the graph, and then it starts climbing up in an equal way. Quadratic functions have that behavior in their tables if you use the right x values. So now we're going to just go over there and make a graph. Negative 5, 8 is up here. Negative 4, 3. Negative 3, 0. Negative 2, negative 1. And now there's a symmetrical pattern to these dots, where if you look at it just right, you'll see that there's basically, you could draw an imaginary line down through the middle of this and it would be perfectly symmetrical on both sides. In fact, we call that line the axis of symmetry, or a line of symmetry. And there is your parabola. We'll be talking about that word a lot in class. And there it is. Done with your homework. Good job. 7 minutes and 37 seconds.